Cutthroat chemistry titration lab, take 3. Forgot to hit the record button last time, and the first one was too long. So let's give her a roll and see what happens. Let's take a look. So we're trying to find the molarity of an unknown HCl solution, and we know it's between 0.0500 molar and 1.150 molar. And you have the list of the different items, so I don't need to go through that. Let's see. So what you're going to do, there is a list of items. If you need to take a closer look at that, I'm going to look at some equations right here. So ultimately, we are going to VAMA equals BBMB. In other words, liters times molarity of the acid, liters times molarity of the base means moles of acid equals moles of base. And at the end point, your moles, you add just enough base where it turns pink, and that's when the moles of base equals the moles of acid. All right, we don't know the molarity of the acid, but we do know the range it's between. We have a choice for how much, but we want to use enough that we can get measurable amounts. And we got a grad cylinder, and we also have a pipette, which is 10 milliliters. So 10 milliliters is a big enough amount that we can measure accurately. And since we have 30 or 40 milliliters, it'll still give us enough for at least 3, or enough for 3 trials. So I really like that. And plus 10 is an easy number to work with. Okay, molarity of the base is 1.00 molar. And then the volume of the base is the difference in Barrett readings from the beginning and the end. Now notice if you use 1.0 molar and you plug things into this equation, you're going to only use the 1.00 molar. You'd have between like 0.5 and 1.5 milliliters. And you can't, if you got a couple tenths of a milliliter off in your titrations, which is pretty easy to do, you're not going to have a very accurate measure there. So the thing that you should do is make this molarity comparable to that of the acid. So instead of adding like about 1 milliliter, you're going to be adding about 10 milliliters. So I would dilute this by a factor of 10. 0.100 molar, you put 10 milliliters of the 1.00 molar NaOH in, and you add 90 milliliters of water, and you have the equipment right there to do that, as we will see. Once you do that, now you have 100 milliliters of base. You can rinse the Barrett as needed, and you have extra stuff to do multiple trials. You rinse your glassware and do the things you need to do. So now with that, you'd expect it to be about, if it were right in the middle, it'd be 10 milliliters, but we expect it to be between 5 and 15. Okay, and that would be just by back plugging into this equation and knowing everything else and working that through. Okay, let's go take a look at this in action so you can actually see the titration, so you can do that in the lab. And let's see, so we have, I will start with our base, I think, and I'm going to go down here, and I have this, I'm going to get a new pipette bulb. I got 10 plus milliliters. So what I'm going to do is just draw off the liquid to get to 10. Okay, so I'm going to draw off enough liquid. Okay, seems like I need to get rid of a little bit more. Okay, to get to 10. And then, if you're worried about it, you could always save it. Whoops. I didn't want to do that. Okay, so now I'm down to 10 milliliters of this liquid. Now, instead of just dumping it right in here, I'd like it to mix better. I think I'm going to put some water in here, and I think it'll be a little quicker to just pour. Okay, so I'm going to fill it halfway, 2/3, whatever. I'm going to pour this in. Now, I know there's a lot of base still sitting in this red one right here. So what am I going to do? I'm going to put some water in here. I might just fill it up to the top. Looks like it's pretty easy to do with this squirt device. I'm going to do that. I know it's not mixed super well, but now I'm thinking I got pretty much all the base out of here. Certainly could do one more rinse in there if you felt like you needed to, but I think that's pretty good. And then I'm going to go up to the 100 milliliter mark. So I measure that up to 100 milliliters. And then what I did was I actually have a beaker that I rinsed out. Now this I rinsed out, I left a little water residue on because I didn't really worry about that because we were adding water. But this one I rinsed out because I don't want to add water to it, and I dried it. And now I'm going to pour it back in here. Okay, and then I'm going to pour it back in here because I know that might not be mixed real well. It's really hard to mix in a grad cylinder. I don't know if I really have to pour it back into the grad cylinder. I'm probably going to just stir it around. And I like to keep it in the beaker. So now I know that's mixed well. And the next thing I'm going to do is go to my So now I got my 0.100 molar. I did a dilution, 10 parts or 1 part, 10 milliliters of 1 molar, and then 90 milliliters of water. I'm going to go to my tube here, and I think I'm going to just dump this out. I'm going to drop the base in here. Okay, and I probably should use a funnel, but I'm not going to grab that. I would probably recommend it. And I might fill it like half full. I know I got, I wouldn't fill it as full if I were worried about how much I have, but now I got 100 milliliters. And I'm thinking that it's a 1-to-1 ratio. I think I got 34 milliliters of acid. So I should have plenty to play around with. So this is about half full. I don't know if you can see that. I might run a little out the barrette bottom. So I'm going to do that. I'm opening the barrette. Guess I'm running it onto the table, and hopefully I don't spill there. And then I'm just kind of rolling this into the sink so that it meets all the parts of this right here. Okay, so now I empty the barrette. Okay, sometimes you get a little puddle down there. You got to knock it through with some pressure. If you get a little water at the bottom of this, I don't know if you can see that right there. If you get a little water back in there, but this one looks pretty clean or pretty good right there. Okay, this one's kind of a really fast barrette, so it's less likely to pool up. The opening is pretty large with that. Okay, let me just wipe up this base that I dropped over here. Okay, and okay. So the next thing I'm going to do is I'm going to take, let's see. So I got my base. Oh, I got to put some stuff in the barrette. So I know this is my base right here. And what I'm going to do is I'll probably use a funnel this time. And I'm going to go up and pour this in. I want to see that, make sure the valve is closed down there. And I'm going to add that. Sometimes it's a little tricky and it likes to leak out, depending on the size of the funnel. So just kind of hold it away, hold it above. So hold the funnel above so there's a little air space so that the air can escape as you add the liquid. So I'm going to fill that mostly up. Okay, I think that's pretty good. Let that drain back down. I like to take the funnel out with that, and it's right about right here. Now, before reading that, I'm going to grab a different beaker right here. And this beaker, what I'm going to do is there's usually air when you fill an empty barrette. So I got to get rid of that air. So I'm going to burp the barrette. Okay, and you could hear that air coming out, just like a baby when it's got air in its tummy. So you burp the barrette, get those air bubbles out, or air bubbles, depending on how you want to do that, but they will cause air. I'm going to go to a black backdrop because I can't see. These have white numbers, and it looks like I'm right at about 17. It looks like right on 17 at the bottom of the meniscus, 17.0. Make sure you know they go from top to bottom. You're not subtracting numbers. You're not doing anything, or you're not subtracting from the 50 because it goes into here. You really don't know how much is in there, but you're just going to take a beginning reading, an ending reading, and then just take the difference between the two. Okay, so I'm going to call it 17.00 because it reads the nearest tenth. So I'm going to estimate one place past that, and it just so happened to be on 17.00. Okay, with that in mind, what I got to do is now I got to get my acid and I got to get it in this flask. I rinse this out. It's got a little water residue there. I'm not even worried about that. And now what I'm going to do is I could rinse this out really good and use a grad cylinder. That would be pretty accurate to do. Or I could use this pipette, and especially you had one that wasn't open yet, so you could use that right away. And then I'm going to go do that with mine right there. So you don't really even have to rinse it because it was already open. And then what I'm going to do is put this pipette bulb on, and I'm going to get my 10 milliliters because that's what I chose to do. And I'm going to put this in, draw up to the 10 milliliter mark, or actually a little bit past the 0 because it goes in the other direction. Okay, and it looks like it's holding. I got a pretty good one right here. I'm going to drop a little bit out. Quick. Okay, that looks good. And then here's my flask. I'm going to drop it in here. And then what I'm going to do is tap the glass, get that last bubble out, little pipetting thing. And then I have this piece. So I just use this thing as a draw, pulled up on it. I can show you that if you have questions when you're doing that in lab. Okay, so the next thing is I got my 10 milliliters of this unknown acid in here. Better add phenolphthalein, otherwise it won't change colors when I reach my endpoint. 1, 2, 3 drops. You know, if I added 4 or something because I was looking up at my video and didn't notice I added it, it's going to be fine. I'm going to come over here. I'm going to angle this a little bit so I can get at it and work with it. And now I'm going to drop the base, and it's going to get, now I know I should be able to run out 5 milliliters pretty quick because I know it's going to be between 5 and 15. If you overshoot though, what happens is, you know, for the next time. So I'm not too worried about the first trial. You got multiple trials. You could use the first one to get a range, but I'm going to try to do this one right here because I'm running out of time for this video, and hopefully I can kind of nail it because I just want to do that. So I'm really kind of gambling. I got that really, really pink, and I think I'm within a couple tenths of a milliliter of getting there. So I kind of know what to predict. So I made the solution, I did the calculation, but you won't know that, and I'm definitely within the range that I need to be. So I'm over 5, but I'm less than 15 right now. Okay, that's not a lot of hint for you, and I'd probably add 1 drop at a time. This is a really fast burette. I guess I went with 2, living a little bit dangerously. But if I look at, I can say, boy, each drop is like 1/10 of a milliliter, 1/2 of a milliliter. Then I know. So you can kind of look back. Notice I had a little bit of water. That might have went over the top. Sometimes I might squirt a little water in there just to make sure that all that got down in there. Extra water is not going to have an impact. And I think I'm 1 drop away. So I'm going to read this just to make sure what it is. And then I'm going to add this extra drop. And I add that. And notice that extra drop made it quite pink. It's staying. Is that sticking around for 15 seconds? I think I'm right at the end point, so I'm going to read that and use that. It's still faint pink after 10 or 15 seconds. Okay, you may or may not be able to see that faint pink. You know, if I'm like, I think that's probably right on. I'm going to just put 1 more drop in for good measure, but after I just read it. So I just read it. Okay, I'm going to add 1 more drop just to see what that looks like. And to me, that probably looks like an over titration, but how much is it over? It's 1 drop, so you'd still get an accurate measure reading it from right now. So the difference between when I read it before and that is only 1 drop, so you're getting a good volume. Although if you're going to try to drink it, you know the pH is a lot greater than 7. We're not going to do that. Okay, so now I can get my reading. I'm not going to really tell you what that is, and then I'd be able to figure out my MA, VA equals MB, VB, and ultimately figure out the molarity of the acid. So I just take that for the volume of the base, the difference from the beginning and the end, and then subtract those. Okay, I think that's probably all I need to show you for that. Hopefully that helps, and then you can come back in lab and do it, and hopefully we didn't go too long in this video. So I'm going to end it. Thanks.